Tutorial, I will explain to you some tricky ways in order to determine the type of a given chemical reactions. Now you need to know that we have 5 types of chemical reactions, and those 5 types are combustion reaction, synthesis, decomposition, and the last two, single displacement, or sometimes some people they call it single replacement. So it's the same, single displacement reaction and double displacement reaction. So first, let's begin with the combustion. We have 2 types of combustions: the combustion that is said complete and the combustion that is said incomplete. Always in a combustion, it's burning in presence of oxygen. Now, when oxygen is present in sufficient amount, in excess amount, the product we obtain is carbon dioxide and water molecules. So therefore, since here we obtained CO2 and H2O, therefore this reaction is a complete combustion. Looking at this second example, I have oxygen, I am burning, but the product obtained is carbon monoxide. And in some reactions, you will also find it as just carbon plus H2O. So in this case, this is an incomplete combustion because the oxygen is not enough. Here's another example. I obtained CO instead of CO2. So this combustion is an incomplete combustion because the levels of oxygen are not sufficiently enough to give me carbon dioxide. That's why I obtained carbon monoxide. Now let's look at this example below. We need to classify the type of these reactions. So looking at this example, I have hydrogen molecules and oxygen molecules, and when they reacted, I obtained molecules of water, H2O. In this case, we are looking at a combination, a synthesis. The synthesis reaction, we always end up with one type of product. One type of product, it means that we have a synthesis reaction. Now let's look at an opposite one. I have here strontium chloride, SrCl2, that was broken down, decomposed into 2 products, Sr and Cl2. The reaction that you have one type of reactant splitting into 2 or more products is called a decomposition reaction. These are basically opposite to each other, the synthesis and the decomposition. Now let's look at the replacement. Wait, one more. I have here one more example. I have one reactant splitting into 2 products. So therefore, this is a decomposition reaction. Now, let's look at some replacement examples. So I'm gonna label here, I'm gonna use this one. I have A coming with B and C coming in D, 2 different compounds. Now A is with D. This one and this one are now forming a compound, and these 2 are forming a compound. Therefore, we switched the metals in this one, A, we switch it with C, and we are looking at a double displacement reaction. Another example, we can see it over here. You have to compare what do you have, and it's like color the same atom with the same color. So this is sodium, I'm coloring it with green, and I'm gonna color the OH with red. So first the green was with the red, and now they are separated. And I'm gonna color iron with blue, and I'm gonna color chlorine with yellow. So look at the switching of colors. It was green and red, blue and yellow. Now it's blue and red, green and yellow. So we are looking at a double displacement reaction. Finally, the last example is an element plus a compound, A plus BC. So you replace B with A, so it becomes B plus AC. Or like in this example, magnesium, I'm coloring it with yellow. It was alone, now it's in a compound. Now hydrogen was part of HCl compound, and hydrogen is now alone. And here's the Cl, now it is joining the magnesium. So this one, since we have an element with a product, it would be called a single displacement reaction.